Welcome to the deep dive. Today we're tackling something pretty specific, but really important: electric remote power monitoring systems. You might know them as eGauges. Our mission: to cut through the complex tech guide and give you a clear, quick understanding of how this works and why it matters for energy management today.
Absolutely. And, this isn't just about getting a better electricity bill. It's fundamentally about visibility,
Yeah.
real-time visibility into how much power you're using, sure, but also the quality of that power. And that real-time data unlocks some key things: accessing info from anywhere, getting automatic alerts if something's off, and I think maybe the biggest one, predicting maintenance needs before a critical failure.
Okay, let's unpack that. When we talk about an eGauge system, what are the pieces, like the architecture?
Right, so think of it in layers. Down at the bottom, you have your field devices. Those are the actual e-gauges, the sensors on the equipment.
Doing the actual measuring.
Exactly. Then you need the communication infrastructure to get that data moving. Could be wires, could be wireless, depends on the setup. That data often hits some sort of data processing layer first. Think edge computing, cleaning things up, maybe doing some quick analysis right there.
Before sending it all up.
Precisely. It all usually ends up in a central management platform, often cloud-based. That's where, you see the dashboards and run the reports.
Got it. So that's the flow. But how does the measurement itself work? I mean, you're dealing with potentially huge amounts of electricity.
Yeah, that's where the clever hardware comes in. You can't just hook a meter directly to a massive industrial line. So you use things like current transformers, CTs, and potential transformers, PTs. Their job is basically to scale down those big currents and voltages to safe, measurable levels.
Okay, that makes sense. But the guide talks about really high precision stuff after that.
Yeah.
Like analog to digital converters, ADCs, with 16 or even 24 bits. Sampling simultaneously across phases. Why such overkill? Can't you just get an average reading?
But that's the core difference. That's what separates modern e-gauges from, well, older meters. If you don't sample super fast, like 128 or 256 times per electrical cycle, and perfectly simultaneously across all the phases, then the power calculations you make later are just fundamentally inaccurate. It's like timing a three-person race with three separate stopwatches started at slightly different times. You won't know who really won.
Okay, so that synchronization is key. It gives you a perfect snapshot across everything at the exact same millisecond.
Exactly. It guarantees phase accuracy. And you need that phase accuracy to calculate things like, well, real power, the actual usable energy you're consuming and paying for.
Right. So you've got this super clean, synchronized high-res data, thanks to the ADCs and the simultaneous sampling. Then the DSP, the digital signal processing, gets involved. What does it do with all that fancy data?
So the DSP takes that rich data and does the heavy lifting. It often uses techniques like fast Fourier transforms FFT analysis.
Okay, what's that for?
That breaks down the electrical waveform to see its components, specifically things like harmonic distortion. Harmonics are like noise on the power line that can cause big problems for equipment. Identifying them is crucial. And then it calculates the important electrical parameters. The big one is real power, often shown as P. And that calculation, P equals V times I times the cosine of the phase angle.
The phase angle again.
Yes, you need that precise phase angle, which comes from the synchronized sampling, to get the cosine part right. That tells you your power factor, basically how efficiently you're using the power delivered. Without sync, you're just guessing.
Okay, that clarifies the how. Let's shift gears. Why are companies actually installing these? It sounds sophisticated, maybe expensive. What's the payoff? The so what?
It really boils down to financials most of the time. The ROI can be pretty quick. First off, demand charge optimization. Utilities often hit you with massive fees based on your peak usage. E-gauges let you see those peaks coming and manage your loads to flatten them out.
Avoiding those huge penalties.
Exactly. And they instantly spot energy waste, maybe a machine left running, or inefficient equipment. Plus, improving your power factor often helps you avoid another set of utility penalties. It's about efficiency and cost avoidance.
And this is just for massive factories, right?
Yeah.
Where else do you see them?
Oh, definitely not. Commercial buildings use them all the time. Think tenant billing, you need accurate data to charge tenants fairly. And for optimizing complex systems like HVAC, which can be a huge energy hog.
Right.
And yes, industrial plants rely heavily on them for process optimization, making sure production lines are running efficiently, scheduling heavy loads for off-peak times. It's pretty widespread.
Looking forward now, where is this technology heading? It feels like it's already doing a lot.
Well, the next big wave is really about adding more intelligence. We're seeing a lot of integration with AI and machine learning, meaning the system doesn't just report data, it starts predicting outcomes. Predictive analytics for equipment failure. Hey, this motor's vibration pattern looks off. It might fail in the next 2 weeks. Or automated anomaly detection that's smarter than simple threshold alerts.
So it gets proactive, not just reactive.
Exactly. And this is all being enabled by the broader Internet of Things trend. More sensors, more data, but using edge computing to handle a lot of it locally so the whole system stays scalable and responsive, even with potentially thousands of devices connected.
And zooming out even further, there's a big connection to sustainability goals too, isn't there?
Absolutely critical. For companies serious about environmental targets, eGauges provide the granular data you need for accurate carbon tracking and reporting. You can't manage what you don't measure, right?
Makes sense.
They're essential for monitoring how well renewable energy sources, like solar panels, are integrating into the facility's power mix. And crucially, they generate the auditable, reliable data that corporations need for their ESG reporting, environmental, social, and governance. That's becoming non-negotiable.
So it starts with precise measurement, leads to efficiency and savings, enables smarter operations through AI, and underpins sustainability efforts. Quite the journey for a meter.
It really is. Which brings us to a final thought, something for you to mull over. Considering how vital these e-gauges are becoming for monitoring power quality, for driving efficiency, how deeply connected is the future of the smart grid and maybe even global energy stability to really widespread adoption of these kinds of precise real-time measurement technologies? Something to think about.